All right, moving on to our mean value theorem. So here we go. So this has two criteria, not one, like Rolle's theorem. This has two criteria. So what this is saying, as long as the function is differentiable and continuous, then what I have, and I'm going to try to draw a picture here. So here's my A and here's my B. So the y values at these 2 points do not need to be the same. So if I have this function, looks something like this, right? Again, the y values do not need to be the same. This is saying this side here, this is the secant line slope. So if I look and where the secant line is between these 2 points, A and B. So I'm going to attempt to draw a secant line. Remember, secant line is a line between 2 points. So there's the line between the 2 points, and this would give us the slope of that secant line. What this theorem is saying is that there is a value of C in between, and there could be more than one, where the slope of the tangent line is the same. Slope of the tangent line is the same, so there are places where the slope is parallel. So here would be a value of C, and here would be a value of C. All right, so let's go and solve, or so we can do this and solve and find these values of C for this function. All right, so I've got this graph with 0 to 9. So is it continuous on 0, 9? It is continuous on 0, 9. I can draw without lifting my pen. Is it differentiable between 0 and 9? Good thing that I didn't include the endpoint, because that would not make it differentiable, because it's not differentiable at endpoints. All right, so it satisfies the criteria, so let's go do it. So I want to say I'm going to set the derivative equal to f of 9 minus f of 0 all over 9 minus 0. So f of 9 means put 9 in here. So I'm just going to go really slow so you see what I'm doing. And I'm going to take the derivative on this side. All right, so I'm going to rewrite this as the fraction that it is. And from this side, I get 3 over 9. All right, so I'm going to cross, well, let me do one more step here. So 1/2, 1 over root x is equal to 1/3. So let me multiply this root x up and then multiply this 3 over here. And now I'm going to square both sides, so I get 9/4 to equal the x. So that value is in between 0 and 9, so that's the value of C. That's the C value, the 9/4, that satisfies the mean value theorem. All right, let's look at this one. So here I have this interval here. So let's first see if it satisfies the criteria. This is continuous on -2 to 1, because it's a nice parabola. This function is differentiable between -2 and 1. Okay, so let's go find and set up. So I'm going to encourage you to just kind of go slow. So the derivative equals, so I want f of 1 minus f of -2 all over 1 subtract a -2. So the derivative goes on this side. And over here, I'm going to substitute 1 into my function. That gives me 2. Then I'm going to subtract off, substituting in -2. So I get 4 minus 2. And then down here, I get 1 plus 2. So that gives me a 3. So 2x plus 1 equaling. And so on this side, I get 2 minus 2. Oh, that gives me a 0. So then that gives me an x equaling a -1/2. So the value of C that satisfies the mean value theorem is -1/2, and it is in this interval. Let's stop there, and I'll continue with the